Look at this photograph of our planet. Without any artificial lines or markers, we face an immediate problem. How do you communicate your exact location across a featureless 24,000 miles spinning sphere of water? Human ingenuity solved this geographic chaos by overlaying an invisible mathematical net to organize the world. This wireframe diagram shows the first piece of that solution, the equator. This horizontal baseline exactly through the middle slices the Earth into northern and southern hemispheres. Next, a vertical baseline, the prime meridian, slices the planet into eastern and western hemispheres, leaving 4 perfect quadrants. These 2 intersecting 0-degree lines give us an absolute foundation. But to find a specific global address, we have to build out the rest of the mathematical net. This animation illustrates lines of latitude, or parallels, wrapping east to west to measure distance north or south from the equator. Lines of longitude, or meridians, radiate vertically to measure distance east or west. At the poles, parallels remain parallel, but meridians converge. Combine these 2 sets of lines, and you get an exact point of intersection. 40 degrees north and 74 degrees west drops you in New York. 29 degrees north and 77 degrees east places you in Delhi. A geographic coordinate pair is more than just a point on a map. These 2 numbers are the mathematical shorthand for a location's climate and specific time of day. Here we see a model of solar radiation striking the Earth. Because the planet is curved, incoming sunlight hits different latitudes at vastly different angles. The central red band marks the torrid zone. Here, direct sunlight creates consistently hot climates. Outward, green and yellow temperate zones receive angled sunlight, creating distinct seasonal variations. Finally, icy blue caps mark the frigid zones. Sunlight barely grazes these latitudes, resulting in extreme cold. This photograph shows the physical reality of those extreme polar latitudes. It is a harsh, frozen environment completely starved of direct solar energy. Latitude tells you how far you are from the equator, and that distance dictates the thermal reality and biological survivability of a location. If horizontal lines determine our climate, vertical lines govern our time. This top-down diagram breaks down the math of a spinning planet. The Earth completes a full 360-degree rotation every 24 hours. That means it turns exactly 15 degrees every single hour. Longitude is literal time. The longitude pavilion at the Greenwich Observatory. The prime meridian runs directly through this building, anchoring the global clock and establishing Greenwich Mean Time. Watch this animation of the globe passing through a fixed zone of sunlight. Delhi sits at 77 degrees east longitude, so it rotates into the sunlight and hits solar noon roughly 5 hours before London does at 0 degrees. To avoid the chaos of every town following its own solar noon, countries adopted standard time. India uses the 82.5-degree east meridian to keep the entire country synced exactly 5.5 hours ahead of Greenwich. Opposite the prime meridian is the international dateline, a zigzagging border at 180 degrees longitude where calendar days change. Fly east across it and you subtract a day. Fly west and you move a full day into the future. By organizing the planet into these vertical slices, humanity is able to synchronize global trade and communication across every continent. Increasing energy, watch as we assemble all these layers. The blank sphere we started with is now a highly organized, mathematically sound system. This photograph captures a navigator reading his position from the stars. For centuries, explorers relied on this grid to find their way across open seas. This map traces the network of oceanic communication routes connecting the continents. Today, this grid provides the mathematical structure for global shipping networks, GPS satellites, and international communications. This means that by using just 2 numbers and 2 letters, you can determine the location, the climate, and the time of any point on Earth.